Malaysia has great potential in solar, and it's attracting many companies to invest and build factories here. At the same time, some companies have brought advanced products and technologies to promote and boom the market. Next, let's go ahead with Trina Solar to learn about the latest product of manufacturers. Mr. Lin Chongbo, Head of Product and Marketing of APAC Trina Solar, will give a technology showcase with the topic, Trina Vertex Series, the ideal module for large-scale solar projects. Lim is handling product and marketing in APAC at Trina Solar. He has over 9 years of PV industry experience and supporting a broad base of customers in different segments on product and technical matters. Now let's welcome.
Thank you, New Venture. So once again, thank you everyone for the time today. I'm Nick from Trina Solar. So let me share my screen. Okay, I hope everyone can see my screen now. Okay, so once again, thank you for the time and stay safe in these COVID times. So I'd like to take this opportunity to give an introduction about Trina Solar and our Vertex series. Just some background on Trina Solar. We are founded in 1997. We have over 20 years of experience in the PV module manufacturing. And of course, one of the key highlights that we have been world number 1 in 2014. And from there, we are always in the top 3 solar manufacturers on a global basis. Then last year in 2020, we have relisted onto the Shanghai Star market and also launched our 210 mm high power modules into the market. So in terms of globalization, we are cumulative shipment of about 70 gigawatt as of March 31st, 2021. We have supplied to over 100 of customers on a worldwide and have more than 15,000 employees. So basically for ASEAN and Asia Pacific, our regional HQ is in Singapore, and where we support the ASEAN market, India, Australia, and also to the west of India to some of the Middle East side. So in terms of bankability, we are ranked 5 times in a row top most bankable module supplier by Bloomberg New Energy Finance. So our footprint in APAC has been significant. So over the last 3 years, we have shipped almost 9 gigawatt in Asia Pacific, and we are definitely one of the top 3 players in the region. So in terms of new leading technology, so as mentioned, we have launched our 210 mm high power modules. So this is one of the pioneer in the industry to use this large wafer to make into the solar module. Then as my colleague Alba mentioned earlier, we are also looking into the N-type popcorn technology, and this is expected that to be available very soon in the next quarter. Then at the same time, in terms of the advanced HJT technology, is something which we are also reviewing. So we are working on the different manufacturing to see when we can officially commercialize it and then bring it to the market to offer even better technology and higher power for our customers. So this is just some background on how module power has developed over the last 10 years. So it has been especially exciting for the last 2 years since 2020, where we started off the 500 watt, and then in a span of just 1 year plus, we have almost reached now to 700 watt. So this is using the combination of different technologies, including the larger cell and of course the P-type module. So we do see the interesting trend that since June 2021 in SNEC China exhibition, you see that over half of the module suppliers have exhibited 210 mm modules, with the power being ranging between 600 to 700. So this is definitely an up and coming trend, which will slowly adopted by most of the manufacturers in the solar industry. So Trina here ourselves, we have also supplied many projects using our 210 Vertex module. So on a global basis, we have supplied to Europe, America, Japan, and also in Asia Pacific, including projects in Singapore and also Vietnam. This is our complete Trina Vertex family. Starting from the left, we have our Vertex S. So this is the 400-watt module, which is targeted for residential market. And then in the center, we have the 1819 series. So this is mainly for rooftops and commercial and industrial rooftops. So between power bin will be ranging from 500 watt to 550 watt. Now on the right will be our 20 series and 21 series. So these are used for large utility projects together with the trackers. So these power bins will be from 600 to 607. So basically our Vertex family can cover all three segments of residential, commercial, and industrial rooftops, and also ground-mounted utility projects. Of course, there are other special projects like floating agriculture, complementary PV project, fishing, complementary PV projects. So this can also be deployed using Trina Vertex module. So this is some of the technologies that we have put into our solar modules. So starting from the top left corner, we'll be using of the large wafer size, which is 210 mm. Then because the wafer size is increased, we also increase the number of bus bar. So you can see we are using 12 bus bar. And then as the wafer size become bigger, we also upgrade our cutting technology. So we have changed from the previous high temperature laser and mechanical to using non-destructive cutting. So this is using a low temperature laser to slice through a cell. So this will enable us to maintain similar mechanical integrity of the cut cell as compared to the full cell. Then lastly, we also use the high density interconnection technology, which is basically to minimize the space between each cell so that we can improve the module efficiency by 0.2 to 0.3%. So let me go a little bit more detail into our Vertex series, which is available in both bifacial and monofacial. So our range basically for these larger footprint modules, it will cover power bins from 550, 600, 670 watt. So you can see here, this is our 550 19 series product information. So as mentioned, we are using 210 mm cell, multi-bus bar, non-destructive cutting, high density connection. And this is based on a 5x11 layout, so there's 110 cells, and it's all half cut. An interesting point to note is that for Trina, we adopt this low voltage, high current design. So as compared to the others, for example, the 182 family, the VOC of the 182 will be approximately in the 47 to 48, 49 volts range. Whereas for Trina Vertex, our VOC is at a 38.1 volt range. So how does this help in terms at the system level? So you can see here, we can connect more modules per string. So this gives us total power per string will be higher as compared to the others. So when we have a higher power per string, actually have an impact onto the BOS cost, which will enable us to get some savings at the system level. So this is an interesting table which shows how the system voltage has changed over the last 10 years. So, maybe 10 years ago, people are all familiar with 600 volts, and then there's 1000 volts. And it took a little bit of time before we transit over to the 1500 volts. So you can see here, as the module power increases, and with Trina low voltage design, we are actually able to connect more modules per string, and this helps to achieve more savings in terms at the BOS level. So next is our ultra high power 670 watt module. So you can see here, this is a 132 cell, 2x66 layout. So the dimension is about 2.38 by 1.3. So we are also offering it in the backsheet monofacial and also the double glass bifacial. So similarly, it's also based on the low voltage design concept. So we have worked with third-party analysis agencies. Like previously, we have worked with DMV, and this time we have also worked with Fraunhofer to do the simulation using Trina Vertex module as compared to the other module types in the market. So there's two different scenarios that we have chosen. One is in Germany, using a fixed tilt installation, and then one is in Spain using a one-row tracker configuration. So overall, the conclusion is quite obvious that when we use the Trina high power modules, we are able to achieve the best LCOE at both the location. So we also have a lower BOS cost because of our higher power output. And the other additional benefits will be the other savings in terms of the BOS cost because less strings are needed because of the higher power per string. So details of the report are available. If you are interested, please contact Trina. We are happy to share with you on the details of this report. Okay, so next, I also like to talk a bit on our reliability because Vertex module is, I would say, relatively new, as also the 210mm. So we do have a lot of questions from different areas or doubts from different areas questioning, whether can modules be so big and be stable to use for the system level. So over here, we have done a lot of extensive testing and designing of the module. So based on the testing and our frame design, we are happy to say that we are able to achieve the standard 5,400 Pascal front and 2,400 Pascal back, which is the basic IEC standards requirement. So in terms of the mechanical loading wise, there's definitely no issue. It is equivalent as compared to traditional module. So this is achieved by optimizing our frame design in terms of the thickness, the frame chamber, the clampings, and the crossbeam connector design optimization. So all this will contribute to making our Vertex module as strong as the traditional module. So in order to showcase this, we have also done various tests, 6 tests actually, which covers the static mechanical load and non-uniform snow load test, extreme temperature mechanical load test, tilt test, dynamic mechanical load test, and also the wind tunnel test. So just a little bit more details. This is based on our dynamic load comparison. So you can see here, when we use our ultra high power 670 watt module, we're able to withstand up to almost 20 times the test with no deformation as compared to the other competitive products. Then another commonly heard question is that having a bigger cell and a higher current result in higher operating temperature of the module. So to answer that, we need to know where is the high current coming from. So you can see we do a simple comparison at for the 210 versus the 182 at the same cell efficiency. So you'll see here the number of bus bar is 12 as compared to 9. And then where is the high current? Basically, the high current actually is at position 1, which is the junction box, and position 2, which is the middle bus bar. Then for the current density at 4 and 5, which is actually on the surface of the cell and also the bus bar. So this is the same as the traditional module. And when the current flows from there onto the cross-sectional string connector, so that is where you can see the current is slightly increased. So over here, we have optimized the thickness and width of the string connector. So this will help to reduce any partial area shading that might occur. So overall, the whole temperature is the same as compared to the other traditional module. So to further prove that, we also perform outdoor testing where we measure the temperature of the module over 1 day to check whether is there any period where the temperature between 210, 166, and 182 is significantly different. So we do see that there is no time where there is very big temperature difference between all the 3 different cell sizes. Then in terms of DC cable loss, so people tend to think that when the current is higher, then there will be more cable loss at the system level. So we need to understand what is DC cable loss. Basically, it is the electrical resistance and part of the electricity is converted to heat, which constitute to this cable loss. So this is actually decided by the current and also by the cable length. Although the 210 mm module is higher in current, but because of the higher power bin, so at the system level, actually the total cable length used is actually shorter as compared to the 182. So based on our case study, it's about approximately about 39% less cable use as compared to the others. So when you put it into the comparison level, you will see that on the right side table, top table, when we compare with the 182, then you will see in terms of the cable loss, once we increase the cable diameter from 4 to 6, then the cable loss is significantly reduced. But at the same time, even if we don't do that, we need to look at the overall DC loss ratio at the system level, which is shown in the second table, where as a DC system efficiency 1 and R efficiency 2. So which results will give us the total PR ratio. So this shows that actually, even if we use a 4 mm square cable, the 210 module is only lower by 0.08%. But once we use a 6 mm square cable, actually our efficiency becomes higher by about 0.23% as compared to the 182. So next is also on the transportation. So, the modules are big. Are we able to transport them safely and also optimize the space inside the 40-foot high cube container? So you can see here on the left is the conventional two-stack horizontal packing. So on the right will be our vertical placement packing on the Vertex module. So this is how it will look like inside a 40-foot high cube container. So you can see that although the pallets per container is reduced, but because of the higher power bin, the total power per container is actually increased. At the same time, we are also providing this assistant tool to help our customers unload the modules safely and also unpack the modules at site, so that we can lean the module towards the assistant tool to make it stable, and then after which the operators or the workers on site can remove the module one by one and carry it to the installation area. So another issue is also commonly highlighted is whether with these high current modules, can they work with the major inverter suppliers? Okay. So you can see for central inverter, there's no problem. We just need to upgrade the fuse capacity from 50 amps to 30 amps. Then in terms of string inverter level wise, we have already worked with top major inverter suppliers. So most of them already have the models that is compatible that can be used with Trina ultra high power module. So if you have any doubts or questions, please do contact with Trina also. We have a comprehensive inverter compatibility checking tool, and we can suggest to you which inverter is suitable for your project needs. Then in terms of ground mounted projects, of course, we see the trend of tracker being more and more used in ground mounted projects. So we have also worked with the major tracker suppliers in the market to make sure that our design can fit in with the tracker design to generate the most value for our customer. So lastly, these are just some of the case studies that we have done before, and we have supplied to the market for industrial and small commercial, where the rooftops we have installed using Trina Vertex module. And of course, for utility projects, definitely together with the tracker, you can also use all these high power modules. Okay, with that, I've come to the end of my presentation. Thank you, everyone. No, I'll back to you.
Thank you, Mr. Lim. Thank you for Trina's continuous support. Our next session will be starting at 3:45. Please, all of our attendees been waiting for a while. Thank you.